Okay, so now what I'm going to do is I'm going to open up the electrical cabinet. So one thing that I suppose I have in my mind with doing any kind of pet project is generally that I want the look to be neat. Now I have to say, what I did was I got the thing working, and then I literally piled all the electrical side into the cabinet, and effectively I didn't go back and fix it. Right, it looks neat on the outside, it looks neat inside the machine, but the electrical cabinet definitely needs it needs work. So first off, anyway, look, I'll bring the camera forward here, and what I'll do is I'll just literally show the side here. So what I have is a switch which turns the drives on, so it gives power to the actual stepper motors inside, and then this is for the actual VSD itself. Okay, so what I'll do is I will open up the cabinet. Okay, so the cabinet is open, and then I literally just go through everything. So as I said, it wasn't that neat, but that's something that I'll get back to at a further point. So this is the VSD, and I'll hit that button I just spoke about there a minute ago. So you'll see the VSD begin to power on. I hope there we go. Okay, so this is what powers the water-cooled spindle. And there's basically an awful lot that can be done with this VSD. It can be controlled through applications over something called Modbus, etc. I won't go into that now. I'll look at that at a further point. Within this. So effectively, what I have is a power supply which gives power to the actual stepper motors themselves. It does that through these drives here. There's 4 drives. So there's 2 on the y-axis, 1 on the x-axis, and then there's literally one for the x-axis. So you've got those 4 motors here. What I have here is something called a breakout board, and I'm using a kind of a classic control philosophy, which is effectively a parallel port on a very, very decent, as I spoke about in another video, a very, very decent machine from about, say, 2007, around that period, where parallel ports were still just about to be phased out. And you can see then that I literally just have power coming in. Literally this is direct mains power, so literally I just loosely kind of put it coming in effectively, and then I literally have the power going directly to a switch, which, as I spoke about earlier, gives power to this guy. This is a 36 volt power supply, so 36 volts up to 15 amps, and then effectively it's literally just a case of giving power to the VSD through the mains again. This is something that I'm not that happy with. Realistically, I should have broken everything out on DIN rails. When I bought the cabinet, I thought it was definitely big enough, but actually putting a very, very neat layout for a machine like this, given all the components that go inside, this is actually just slightly too small. As you can see, I had trunking running around on the outside, and I thought I could just do everything neatly. Effectively, I just got this guy operational. I said I'd come back to it, but it works perfectly. That's the thing, it works flawlessly, no issues at all. One thing I'd say is that when I went off to buy this, I oversized everything. So I oversized the drives. Literally those drives can take triple what I'm putting into it. That's fine, because what I bought was cheap Chinese drives, where whatever their upper limits is, don't even go near it because you fry it. And that's basically kind of what I think. It's again the same way with the VSD. The VSD can literally be ramped up to a serious level. I just keep it at a third of what's needed, and that's my hope then, that I'll never approach this limit where I literally can fry the electronics under strain. So to summarize that, I have a power supply going to the drives, which are going to the stepper motors, 36 volts up to 15 amps. That's fine, because I'm only using half it. Then there's the drives themselves, which you can see these are set. I won't go into the excessive detail on this now about stepper rotations and all this kind of stuff, but effectively I'm not being hard on these. with regards to how they're going to drive the motors. The breakout board, literally just sending signals into the individual drives themselves, pulses literally, and step rotation. And back to this VSD, which has a shielded cable, because there's an incredible amount of electrical noise that comes out of this. So I never had any issues with skip steps or anything like that, because I took it as gospel. I read enough on the forums that effectively, and I suppose I'd know this academically and professionally as well, that VSDs literally cause havoc with signals. So even the way I wired this section here, I kept the VSD wire completely away from the breakout board all the way over here, and I just think that's extremely important to note.